Hi, this video gives you everything you need to know about congruent triangles for your high school geometry class. So we'll start with an overview. And you may be thinking this yourself, what is with this word congruent? It's not a very natural word. Well, congruent means that two geometric figures have the same size or shape. And you say, well, why is that the word? And so let's look at other words that you can more informally use. And maybe you could say, well, these two geometric figures are the same. Well, you can't really say that because they're not actually the same figure. They're two different figures. And you can't use the word equal because equal is for comparing numbers, not geometric figures. And you can't really use the word alike because that's kind of fuzzy, and figures can be alike but still not have the same size and shape. So we're kind of stuck with a word that is specific to this meaning, and that is the word congruent. So you'll hear this all the time, and that's we just accept that as the word. Okay, so what does it mean for two triangles to be congruent? Well, they're congruent if their corresponding parts are congruent. And triangles have three sides and three angles, and those, for two triangles to be congruent, all three sides need to be congruent and all three angles need to be congruent. So, but these triangles may not be oriented the same way. And so when you look at two triangles, you need to first figure out which sides and which angles correspond to one another. And so here's an example. Like, you see these two triangles. Can you visualize which of the angles correspond to which of the other angles? Which of the sides correspond to which of the sides? And so I'm going to show us here, and you can see by labeling it each angle, you can see how they correspond. So this is the kind of thing when you get a problem in your geometry class, you first have to figure out how the two triangles correspond. And so I want to next talk about, well, why are we even doing this? What really will you do to use this concept of congruent triangles? Well, there's two reasons. The first is you may be making a copy of a triangle, and if you do that, you definitely want the second triangle to be congruent to the first one. And the other reason is if you're being asked to compare two triangles to determine if they're congruent. And so when you're doing these two activities, the question is, do you need to copy or compare all three sides and all three angles? Or could you use a shortcut? That would be to just copy or compare just some of the three sides and some of the three angles. And for example, if you were to copy and compare compare three sides, just the sides, is that good enough to know whether the triangles are congruent? And so we're going to look at what would be the best shortcuts to use for the different, what I call branches of geometry. You'll see what I mean. And then see which of these shortcuts work and which do not. So here's a table that shows this, and down the left-hand side are what I call the branches of geometry. The first one is what I would call pure geometry, which is using a compass and a straight edge like the ancient Greeks did. The next you could call measured geometry, which is using a ruler and a protractor. And then the final one is analytical geometry, where you put the geometric figures on an XY coordinate plane. And so let's look at making a copy of the triangle in each of these, with each of these parts of the geometry. And for pure geometry with a compass and a straight edge, it's easiest to just copy the three sides. And so the way you would do that is you could start with a triangle, and then you measure one side of the triangle with the compass, and then you draw an arc with that compass, and then you can draw the first side just like that. Then you measure the second side, and you draw an arc for the second side, and you measure the third side, and you draw kind of a crosshatch arc for the third side, and then you can draw the second side and the third side, and that's it. When you're doing this, you're not paying any attention to angles, so it's all about measuring the sides. So again, the question, are these two triangles congruent? And so the next one is measured geometry, and for that, the easiest way, you start with to copy a triangle, and you start with a triangle, and then you measure the first side and you draw it. Then you measure the angle between the first and second side, and you draw a dot for that angle. And then you measure the second side, and you draw that second side through the dot at the right length, and then you draw the third side. And so in this case, we're using the size, a side, and then an angle, and then a second side. And the angle's what's called included between the two sides. It's between the two sides. Now, are these two triangles congruent? And then finally, in analytic geometry, what you do is what's called translating. You translate the three vertexes of the triangle and draw the other triangle. So translating just simply means move, if you remember from your transformation section of geometry. And so let's say we have these three vertexes of this triangle, and then you translate these vertexes, and in this case we're copying these vertexes 6 units in the positive direction along the x-axis, and then you write those vertexes, and then you fill in the sides. And in this case, we're just measuring the sides. We don't have anything to do with the angles. We can't even really calculate the angles without trigonometry. So we're just focusing on the sides. Now, if we look over on the right and we talk about comparing triangles, you can compare corresponding parts, or another technique is to do transformations until one figure covers the other. And the transformations are like translation, rotation, reflection, until one figure covers the other. And both are ways to compare triangles. But the easiest way in pure geometry is just to compare the lengths of the three sides. And again, you're focusing on the sides. With measured, it's easier. You could just measure you can compare the sides or the angles, so you have more flexibility there. For both of those, you can do these transformations, but it's a much more laborious process, and it would take you a long time. Now, for analytic geometry, actually the easiest thing to do is to do these transformations, a translation, a rotation, or reflection of each of the vertexes of the first triangle, and make sure that it matches to the corresponding vertexes of the second triangle. And you do that, and then you can prove that the triangles are congruent. But and so that works pretty well in analytic geometry, but again, you're focusing on the sides. So what we're saying is, for both making a copy and comparing, is this enough information to prove they're congruent? So let's start from scratch and start over and get the big picture. What do you need to know to be able to ensure the triangles are congruent? Well, you can't know just one side or just one angle. It's not enough information. I think that's pretty intuitive. But you couldn't just know two sides or just two angles or just a side and an angle, and it's still not enough information. And I think if you thought about it or tried it, you would see that's true. So what we definitely need three pieces of information, either three information about pieces of information about the sides or the angles, and but which combinations will give us enough information? So we're going to look at that on the next slide. So here is the big comprehensive look at this. And if we look down the left-hand side, we see all combinations of side and angle. And we're going to go through each of these, and we're going to ask, is this enough to prove, when you have this information, these three pieces of information, is it enough to prove that triangles are congruent? The first is side, side, side. And if you know the length of the three sides, the answer is yes, because there is this postulate called the side, side, side postulate that says if the sides of one triangle are congruent to the sides of another triangle, the triangles are congruent. So if the sides are congruent, then the triangles are congruent. Now, I want to say a word, just stop here for a moment to say, what is this word postulate? And I'm also going to use the word theorem. What these are is a statement. And the difference between a postulate and a theorem is, a postulate is, you can't really prove it's true, it's just self-evident. You just know it's true. And then a theorem, you can actually prove is true. But with the side, side, side postulate, you just know this is true. There's no counterexample, we just know it's true. Now for SSA, side, side, angle, and that's where you have a side and then another side and an angle that's not in between those two sides, this does not prove the triangles are congruent because there is a counterexample. And if you look over on the right, this is a triangle that has the same S1, side S1, the same side S2, and the same angle A1, yet it's not the same triangle. So this is not enough information to be able to prove triangles are congruent. However, there is a case that when this A1, this angle, is a right angle, and you have a right triangle, this side angle will work, and we'll see that on the next slide. It's kind of a special case. Okay, the next one is side angle side, and that is you know a side and the angle, what's called the included angle, and the second side, and that answer is yes. And the side angle side postulate says if two sides in the included angle of one triangle are congruent with the corresponding parts of another triangle, the triangles are congruent. The next one is side angle angle. And if you know the side and then an angle and then the next angle there, as shown, the answer is yes. And the reason is there is another postulate called the triangle postulate that says the sum of interior angles of a triangle equals 180 degrees. And because of that, we know if we know two of the angles, like A1 and A2, then we know the third angle. We would know this like question mark, you could call it A3. And because you know this A3, you have angle, side angle, and you'll see below that that is, there's a postulate for angle, side angle. So side angle works. Next we go to the one that's the bad word, and that's the same as SSA, and it doesn't work. It's the same thing. The next one is angle, side angle, and this one you have an angle, a side, and then an angle, and the answer is yes. The angle, side angle postulate says if two angles in the included side of one triangle are congruent with the corresponding parts of another triangle, the triangles are congruent. So that works. The next is AAS, which is the same as SAA up here, same rationale. And then the final one is angle, angle, angle. And the answer is no. And the reason is because you can know the three angles, but the triangles may not be congruent. They could be bigger or smaller, but they all have the same angles, but they are not the same triangle. They are not the congruent triangles. However, these two triangles, when they all have the same angles, they're called similar. But that's a separate subject and another geometry unit, so we're not going to talk about that here. So that's the big picture. There's only two more points to make, and then we're done. So the first of the 2 points is there is another postulate called that says this: corresponding parts of congruent triangles are congruent, and it's known affectionately by the acronym CPOC-TAC. And the way you use this, the reason you use this is when you need to prove that some set of corresponding parts, like does the side of one triangle, is it congruent with the side of another triangle? Or is one of the angles of a triangle congruent with that corresponding angle of another triangle? If you need to prove that, then what you do first is you prove that the triangles are congruent using one of these postulates or other methods for proving the triangles are congruent, and then you simply say CPOC-TAC, and that means that also the sides of the triangle are congruent, or the angles of that triangle are congruent. So that you use that. Typically, you'll see that at the end of many of the problems you're given. Right, the last step is to say CPOC-TAC. Okay, the next thing we want to talk about is the hypotenuse leg theorem, and this is not a postulate; it's a theorem because it could be proven. And so on the previous slide, we said that side-side angle didn't work, and we saw why. There was a counterexample. But in this case, if the angle is a right angle, it does work. And so we have a side, the hypotenuse, and then we have the leg, and then we have the angle, the right angle. These two are congruent, and the theorem says if the hypotenuse and one leg of a right triangle are congruent with the corresponding parts of another right triangle, the triangles are congruent. And so you can see the proof of this if you put these two triangles next to each other, and they form this larger isosceles triangle. And there's a postulate, an isosceles triangle postulate, that says if two sides of a triangle are congruent, then the angles opposite those sides are congruent. So in this case, the hypotenuse and the hypotenuse are congruent, and the angles opposite those sides, that's A1 and A1, they are also congruent. And these angles in this big isosceles triangle are called the base angles, and so they're congruent. And because these are congruent and the right angle, of course, are congruent, then that means by the triangle postulate, this third angle, the A2, they're also congruent. And so these, using the angle side angle postulate, angle side angle, or angle side angle, these are these two triangles are congruent. So the hypotenuse leg theorem works. So this is it. And so all we have left is a summary. And so this is a summary of this video. Two triangles are congruent if their three sides and their three angles are congruent. The purpose of learning about congruent triangles is two reasons. One is when you copy a triangle, you need to make sure the second triangle is the same as congruent to the first. And then another thing you may need to do is be asked to prove that two triangles are congruent. And instead of copying or comparing all three sides and all angles, it's convenient to take a shortcut and only compare some of the sides or angles. And the shortcuts that you can take that work is compare three sides, compare or copy three sides based on the side-by-side postulate, copy or compare two sides and their included angle based on the side angle side postulate, copy and compare two angles, and it turns out any side, so any side and any two angles based on both the angle side angle postulate and the triangle postulate. And then you copy or compare the hypotenuse and one leg of a right triangle, and based on the high leg theorem that those two right triangles are congruent. So one more thing we need to remember is that if you want to prove that a set of corresponding parts of two triangles, like two of the side, the side of two triangles or an angle of the two triangles, if you want to just prove that, you first prove that the triangles are congruent, and then you say CPOC-TAC, and that says that all the corresponding parts are also congruent. So when you're studying, you're in your geometry class, it is very helpful for you to learn, understand, and memorize these postulates and theorems. If you do, then you'll do fine in your geometry class. And that's it. Thanks for listening.